All right, now we're on Calculus Day 23, Part 3. We're going to find values of derivatives using the graphing calculator. For each of the functions below, find the value of f prime of x at the indicated value of x using the graphing calculator. Then determine if the function is increasing, decreasing, has a horizontal tangent, or has a vertical tangent. Give a reason for your answer. So um, let's bring in the graphing calculator. There's a few ways I can do this, and uh, the TI-84 Plus, in this case the Silver Edition, um, takes the derivative one way, and if you have a previous model of the calculator, I'll show you how to do it on that one as well. So on this calculator, let's first just find out where the derivative button is. So I got to hit the Math button. It's in the Math column. I go up, and if you look at choice 8, it says N deriv, and now this says d blank, so I have to say ddx, and now I'm going to type in the value of the function. So we're going to take the time to type in that function right now. When you're up in the exponent, after you put in the x, you hit the right arrow key and it comes back down. So then you type in sine x, you got to close the parentheses. Now, here, there's times you can type in, hey, graph it so that it's a variable, so it just takes the regular derivative. Problem is, if the calculator ever had any number stored in for x or a or m or whatever letter you were trying to do it as, it'll simplify and find out what that answer is. So they specifically ask us to make a equal -2, so I type in my -2. And I'm typing it in this way, and I'll show you another way to do it. I think the other way works. But because that way I can recall it, so because if you look at number 2, it's the same exact function. We're just going to evaluate at a different value. So this is when x equals -2. So let's see what we get. All right, and on the AP exam, we want to go to 3 decimal places, and that's it. So it's going to be -0.538. And let's write that down on the chart. Okay, so let's fill in the chart. F prime of -2 equals -0.538. Answer the question. Since f prime of -2 is less than 0, because it's negative, then the original function f of x is decreasing at x equals -2. Okay, let's do the next example while I already have it up on the calculator, and I'll show you how to recall items on the calculator, and then I'll show you how to do it if your calculator is a different model. So now when my calculator is here, I can retype this whole thing in. That's a lot of work. So what I can do is hit the second button, and above enter is entry, and it'll recall everything that's there. And the next problem just says, hey, do the same exact thing. I'm going to delete -2. And it says find when a equals 1. So I'm going to hit enter, 11.268. And again, we only go to 3 decimal places. So let's write that down. So you can always do that. And I think you can cycle through like 9 or 10 different things that you had previously typed in. Okay, so let's fill that in the chart. And now again, f prime of 1 is 11.268. Since that value is positive or greater than 0, then we know f of x is increasing at x equals 1. All right, now let's look at what if our calculator is a little bit different. So if your calculator didn't go to that ddx, and what I mean here is if it didn't pop into that, take the derivative with respect to x, then you're going to have to type in the function. So in this case, we're using 3e to the x times sine x. You have to say, hey, what you want to take the derivative with respect to. Later on, we'll learn that you can take it with respect to y, to t, all that good stuff. Right now, pretty much everything we've done is to respect to x. We've done a couple with respect to theta. And then what do you want to evaluate it for? And it'll give you that same answer. So why don't you guys try, if your calculator is a little different, why don't you guys try 1 and 2 and get caught up? Great. Okay, so let's do number 3. We got to pay attention to, we're going to do it on the calculator, and we got to pay attention to parentheses and all this good stuff. So let's call the calculator up. Let's go into our math button. I'm going to try to do it a couple different ways. So I can just hit 8. I know it's choice 8. Derivative with respect to x of, now we're going to go natural log, cosine of x, close the angle parentheses, close the cosine parentheses, and with close, what are we at? All over, so we're going to do divided by x squared. X x, and then hit squared. So it's the natural log of, and it just of, if you look what those parentheses are, there's just of the cosine x, and then um, it's all over x squared, and now as x, when x is equal, what is it, pi over 3? So where's my pi? Right above here, pi divided by 3. And we hit enter, and hey, I get this long decimal, and that's going to be our answer. And remember, we're only taking 3 decimal places, so negative 0.3772. All right, so let's write that down. If your calculator won't do it like this, then you have to do it the same way we did it before. So you'd write the function out, and then you would write with respect to x, and then you would write, so comma, x, comma, and in this case, pi over 3. So we just said the derivative at pi over 3 is negative. Therefore, since the derivative is negative or less than 0, then f of x is decreasing at that value. All right, let me show you another way on the calculator to do this problem. So here's what we had before. So now what I'm going to do is I'm just going to go, and just to show you, I had already typed in the function into y1. So there's the entire function. Let me quit that. And sometimes that may be easier for whatever way you're doing it. But now I go to math, choice 8, derivative with respect to x. Oop, come back here. So now instead of typing in that whole thing right there, I'm going to put in y1. So we're going to go vars, y-vars, function, choice y1. And again, when am I doing this? When I'm at pi over 3. Pi divided by 3. And I should get the same answer. And we do. So another way to do it. It doesn't matter what your calculator gives you for a choice here. You can do that both ways. Okay? All right, and now for number 4, I have to find out when it's pi, and I'm just going to show you something. I'm going to use this one up above. I'm going to do second entry. Ooh, that's the last thing I did. Then when I hit second entry again, it scrolls through, and it goes to my previous one. And now I'm just going to kind of come in and delete the 3, delete the divided by. And now for number 4, I'm using all the work that I did for number 3, and I'm just going to hit enter. Uh-oh, non-real answer. Let's go to, and so I get it. I end up getting an answer that is going to be undefined, because the derivative will end up being undefined here. So let's go and write that down. And when I got that non-real answer, that means it's undefined. So the derivative is undefined. We know when the derivative equals 0, it's a horizontal tangent. When it's positive, it's increasing. The original function is increasing. When the derivative is negative, the original function is decreasing. So now when the derivative is undefined, then the original function has a vertical tangent at that value, x equals pi. Okay? All right, so let's keep using the calculator to do number 5 and 6. All right, so I've typed in number 5, e to the tangent of 0.34x, and we're going to simplify this when x equals 0. So let's see what I get for an answer. 0.340. If you don't get that, double check that you're in radian mode, not degree mode. We haven't had to talk about that much, but I think we're all there. And so let's write that down. Obviously, the derivative, which is what I just took on the calculator, is kind of nice. I took the derivative, and it's positive. Therefore, the original function is increasing. As we just said, since it's positive, then the function is increasing. And again, you got to go 3 decimal places, which means you have to leave the 0 there. All right, let's do number 6. Let's first look how we can rewrite this. This is 5 times something, so let's take the 5 out. Sine squared is really sine of ln x, so whatever the angle is or argument is, so sine of the argument all squared. And sometimes it's much easier to think of it like this. Oops, I'm missing a parentheses. So there's the parentheses for, no, I should be good. All right, good. So again, the calculator, it's easier to pay attention like this, because it won't let you write as sine squared like that. So let's do this one out, see if I can get the parentheses correct here. So go math, we're going choice 8, derivative with respect to x of, and if I have trouble in here, then I can always go to my y1 and type it that way. 5 times sine of ln x Let's close that parentheses, close the angle, close the parentheses to close the ln x, and then let's square that. Should be correct. And then I should natural log 1, 2. Oop, no, I gotta put the 1 too close. And then close the parentheses, then square it. So that's 1, 2, 3, because I want to square everything, the sign of everything, 1, 2, 3 there. And I think that's everything. Let me just delete that. I had an extra thing up there, and I'm going to hit over to the right. And what is this? X equals 1. Okay? And again, I know it says A on our sheet, but they're finding it saying what is f prime of A? And then A equals 1. So I'm looking at f prime of x, and it's the same thing. So let's see what we get here. Now, this number, if I write this out, and what that means is, so I have negative 0.1, 2, 3, 4, 5, 6 numbers. And if I come back up here, so that's e to the negative 6. That's times 10 to the negative 6. And then there's a 5. And let's look at that. Then there's a 5. And then a bunch of zeros. What does that number look like? It is f prime of 1 equals 0. Okay? And that's just a little bit, not a glitch, but something that happens with the graphing calculators. All right? And since our derivative is 0, then we know we have a horizontal tangent. Let me write that out. Okay, so since f prime of 1 equals 0, then f of x has a horizontal tangent at x equals 1. All right, I know that's a long video, but that'll be, what was that, part 3. And we'll go on to our last part next. Hopefully that helps with the use of calculator taking the derivative.